going to start our last section, which is find an area between curves. I'm going to split this up into two parts. The first part, we're going to be finding the area between the curve and the x-axis. Sometimes they refer to the x-axis in the book as y equals 0. But in this first part, that's all we're going to do is between a curve, singular, and the x-axis. Now, your first job, regardless of the problem, is graph it. Because example 1 and example 2, we have to work the problems in a totally different way. In the first one, since my curve lies completely above the x-axis from A to B, from my lower limit to my upper limit, I can do the problem exactly how we did the problems back in the last section in 13.5. But if my curve crosses the x-axis, if you remember in 13.4, if I've got any area below, then it is negative. In this section, when we talk about area between curves, it's a gross area. It's total area, and area has to be positive. So in this one, like I said before, what we did in the last section, we do the exact same thing. But if it crosses, we have to go find the 0, because we have to set up two different integrals. We have to take care of from A to C, and then from C to B. Now, from C to B is no issue because the curve is above. But from A to C, it is an issue. We actually have 3 different ways to take care of this, and one of my students saw it last semester. I usually don't say anything about it, but I'll talk about it here in just a second. So the area for example 2, if I have to make this positive, I have 2 ways that we know of. I can multiply that area by negative, thereby making it positive, or I could take an absolute value. Now, I had one student last semester say, well, we could go, do you remember if I go from right to left it will make it positive? That is another possibility. But you know, these normally are one of the easier 2 ways to do it. So really, technically, there are 3 ways. Either are acceptable, but it says in this, what I've got under this example here, in example 2, the interval AC lies below the x-axis, and once evaluated would be negative. So either taking the opposite of the negative area, or the absolute value, or taking the integral from C to A will result in a positive gross area. So I've got an example. First thing I need you to do is graph this function. Now we're looking at it from -1 to 4. So let me get my calculator. I've got the x squared minus 6x plus 5. Let me graph. Now I particularly want to look at from -1 to 4, so I'm going to go change my window. I'm going to put -2 to 5, just to, you know, 1 on either side. It crosses right here. Now I'm actually looking from -1 to 4. I have an issue here. So from -1 to this place, it will be positive, but from here it looks like 1 all the way to 4 it will be negative. So this is the piece I have to fix. Let's go find our 0. Second trace for the calc menu, number 2. So left value or left bound 0, right bound 2. I don't guess. Alright, so from -1 to 1 we're okay, but from 1 to 4 we have to fix in either one of those 3 ways. So first draw the function to see if it crosses. If it does, we have to fix it. Okay, it crosses. So from -1 to 1, notice we take it as is, no issue. Now I did it one of 2 ways. I took the opposite of it, or you take the absolute value. Either one of these, this one or this one, will make this negative area positive. Now it says either expression will equal. Well, let's see. Let me get my calculator back up. Let's do second. Let's do number 7. I'm going to do from -1 to 1. 10.66, let's see, it's 10 2/3, so that would be 32/3. Okay, now I want you to look what happens on the calculator when I do the other one. Let me do number 7 again, and I'm going to go from 1 to 4. It will come up on the calculator, it should, as a negative. Remember, 27 over 3 is 9. I got a common denominator so I could add these together. But guys, that's what I'm talking about. If it's below, we have to fix it. I'm going to show you how to check this thing via calculator. Let me go to the next page, because I do have directions. The only difference when you input the function y, insert the function into absolute value bars. This will make the graph lie completely above the x-axis, and the area will therefore be positive. So I'm going to do the same steps from page 7 down to step 2, and then do the following. Okay, let me get my calculator back up. And go back to y equals. Right here, if you do a second insert, now follow these directions. Math, go over to num, and there's abs. Hit enter. Let's go to the end and close. Now look what happens when I ask it to graph. Remember, absolute value, whatever is here, it will make it positive. So let's see if it bounces. Yeah, there it goes. Now I can do this whole thing at once. So second, calc. Let me do number 7. And if I go from -1 all the way to 4, it should give me this in decimal form. Now, and if you'll notice, it says 19.666601. Ours is actually 19 2/3. This is an exact answer. Whatever the program or routine the calculator is using, it is an approximation, so our answer actually is better than the calculator. But we can use it to check, which is always a great tool to have. So you've got some problems to do. You need to try some by hand, also by calculator, and see how they go. Thank you.